In this video, we're going to talk about some basic differentiation properties. So recall the derivative is defined as the limit as h goes to 0 of f of x plus h minus f of x divided by h. And we denote this by f prime of x. So first, we're going to look at a constant function. And if you remember, constant function, or an interpretation of the derivative, is that it's the slope of the function. And if we look at this function which is constant, again I've drawn f of x equals 2 in our graph, then the slope of that function is just 0. Again, think of slope, rise over run. The rise is always 0, so it doesn't matter what the run is, so the derivative is 0. This is actually fairly straightforward to do as well using the definition of the limit. Again, we don't need to do that work here. So, constant functions, the derivative of a constant is 0. The next rule, really important rule, is the power rule. So if f of x equals x to the n, where n is some real number, it's not 0. Again, if n were 0, then that's x to the 0, which is just 1, which is a constant. So we know how to take that derivative. Then f prime of x, the derivative, is n times x to the power n minus 1. So you take the exponent, bring it down to in front, multiply it by the exponent, and then subtract 1 from that power. Now, just as a side, the equation of a tangent line, and we'll use this periodically throughout this course, the equation of a tangent line at some point c is c to the n plus n c to the n minus 1 times x minus c. And actually, that's worth just looking at where that comes from. So if we want the equation of a tangent line, what do we need? We need a point. Well, the point is c to the n. That's our point on the line. And we need the slope. Well, the slope is the derivative, which is n c to the n minus 1. And the point slope version of a line is y minus y0 equals m, the slope, x minus x0, which is simply y minus c to the n equals n c to the n minus 1 times x minus c. And just rearranging, y equals c to the n plus n c to the n minus 1 times x minus c. I tend not to remember these sorts of formulas. What I tend to remember is point slope version of a line. I need a point, c divided by c comma c to the n, and I need the slope. Take the derivative, plug in the value, and c to the n minus 1. Once I know those two things, I can use this version of my line, equation of a line, and I can solve. All right, example. F of x equals x cubed. Find f prime of x. Well, n in this case is 3, so f prime of x equals 3, bring the exponent down, times x to the 3 minus 1, which is 2. What is the equation of the tangent line of this function at x equals 1? We need our point. 1 cubed is also 1. The slope, 3 times 1 squared, which is just 3. So the equation of our line, y minus 1 equals 3 times x minus 1. If I want to solve for y, that's y equals 3 times x minus 1 plus 1. Let's plug those into Desmos, and let's graph the function and the tangent line at x equals 1. So, draw x cubed, and we'll draw our tangent line, which was 3 x minus 1 plus 1. And we'll zoom in a little bit here so we can see. And you can see the function's in red, the tangent line's in blue. They meet at the point 1, 1, which is our point, and they both have slope 3, the function and the tangent line at that point. And you can see the function just touches and is going in exactly the same direction, has the same slope as our function. In our next example, we're going to find the derivative of the function f of x equals the fourth root of x cubed. So we really need to rewrite this a little bit to make it make a little more sense. So if you recall, this is x cubed to the power 1/4. If we've got something to a power raised to another power, we multiply exponents and we get x to the 3/4. All right, so using the power rule, f prime of x equals, bring the exponent down, 3/4 x to the 3/4 minus 1, which is -1/4, which is simply 3/4 times 1 divided by the 4th root of x, or I guess we could write it as 3 divided by 4, 4th root of x. Any of these answers is fine. I'm totally fine with negative exponents, with square roots or with roots in the denominator, and so on. Constant multiple rule. If f of x is a constant times g of x, then the derivative of f of x, f prime of x, is equal to the constant times the derivative of g of x. So again, multiply a function by a constant, the derivative is the constant times the derivative of the function. All right, so f of x equals 3x to the 4th. F prime of x equals 3, the constant, times the derivative of x to the 4th. Well, that's 4x to the 4 minus 1, which is 3. The derivative of 2 times the square root of x. I like to get rid of the radicals and write those as exponents. So that's 2x to the 1/2. Which means f prime of x equals 2, the constant, times 1/2 x to the 1/2 minus 1/2 to the -1/2, which of course 2 times 1/2 is 1, so that's x to the -1/2. Or if you really want, 1 over square root of x. F of x equals -5x to the 4th divided by x to the 4th. Again, I like to rewrite that. That's -5x to the -4, and now it's relatively straightforward. F prime of x equals -20 x to the -4 minus 1, x to the -5. Oops, that's not right. -20, it should be +20. -5 times -4 is +20. +20 x to the -5, which is 20 over x to the 5th. If you want to rewrite it, either of these solutions is fine. Sum and difference properties. If f of x equals the sum of two functions, f of x equals u of x plus v of x, then the derivative of f of x, f prime of x, is the sum of the derivatives, u prime of x plus v prime of x. If f of x is the difference of two functions, u of x minus v of x, then f prime of x is the difference of the derivatives, u prime of x minus v prime of x. So now we can find a derivative. F prime of x, this is the sum and difference of a bunch of functions, so we take them individually. Derivative of 4, that's a constant, 0. Derivative of 2x cubed is 2 times, bring the exponent down, 3, x to the 3 minus 1, which is 2. Minus 3, bring the exponent down, becomes plus 3, right? Minus 3 times minus 1 is plus 3. 3 times x to the -2. Right? -1 minus 1 is -2. F of x equals 3x squared minus 2 over x squared. I like to simplify a little bit. 3x squared minus 2x to the -2, and now I can take the derivative. F prime of x equals 3 times 2 is 6, x to the 1. Minus 2 times minus 2 is plus 4, x to the -3. Right? Bring the exponent down, minus 2 times minus 2, x to the -2 minus 1 is -3. S of t equals square root of t plus 2. The x doesn't matter whether it's an x or a t or a w or any other letter, doesn't matter. S prime of t equals, this is t to the 1/2, so that's 1/2 t to the -1/2 plus 0. Again, I've used this t to the 1/2 plus 2. Derivative of t to the 1/2 is 1/2 t to the 1/2 minus 1, which is negative 1/2, plus derivative of 2, that's a constant, 0. So we can take derivatives with respect to anything. The letter x or the letter t doesn't matter. It's just a placeholder as long as we're consistent.